Before level 2, the only way you knew how to find the gradient of the line was to take 2 points and divide the change in y over the change in x. You know, rise of a run. But look at this parabola, y equals x squared. The problem with rise of a run here is that the gradient of the parabola is constantly changing. So we're going to have to abandon our good old level 1 skills and move on to something more powerful, differentiation. When we differentiate, we always start out with the equation for a line. If the equation for our line is y equals ax to the power of n, where a and n are just some random numbers, then when we differentiate this equation, we end up with dy dx equals nax to the power of n minus 1. So lots of things have changed in one step. Let's look at what we've done. On the right, y has transformed into dy dx. Since the letter d means change in, then this actually just means change in y over change in x, and that's just the gradient. So dy dx is another way of saying the gradient. On the right, we've taken the original power, n, and we've moved it down to the front of the equation. The last thing we did was to take the original power n and decrease it by 1 to become n minus 1. So if you know how to do those three things, then you can basically differentiate any equation you like. Let's start with our old favorite from before, y equals x squared. When we differentiate y equals x squared, firstly the y is going to turn into dy dx. So we get dy dx equals x squared. Our next step is to bring the power, 2, down to the front of the equation like this. And now, for our final act, we're going to drop the power by 1. dy dx equals 2 times x to the power of 1, which is simply the same as writing dy dx equals 2x. Not all equations start out with y equals. Sometimes you'll see an equation that instead has been written something like this: f of x equals ax to the power of n. The f of x just means the function of x, and to be honest, it's not really any different to y equals. When we go and differentiate the right side, the derivative, which just means the differentiated form of, will be exactly the same. On the left side, f of x simply changes to f prime of x. So if we take f of x equals ax to the power of n, and we differentiate it, we'll end up with f prime of x equals nax to the power of n minus 1. When you get given equations that contain more than just one term, how do we differentiate those? What we're talking about is something like this: f of x equals 3x squared minus 6x plus 5. We've got a single equation, but that equation contains a 3x squared, a 6x, and a 5. Well, it's actually really simple. All we need to do is differentiate each term individually, and then string them all back together. We can work out that 3x squared turns into 6x, 6x turns into 6, and 5 turns into nothing. And so we change the f of x into an f prime x, and then we slot everything back together like this: f prime x equals 6x minus 6. Easy. So that's essentially how you differentiate, boys and girls. If you can do this, then things really don't get that much harder for you. Sometimes we run into equations that look strange, and it seems like there isn't any way to differentiate them at all. Like this equation, for example. This equation is y equals the square root of x. All we need to do is rewrite the square root of x as something with a power. Y equals x to the power of 1 over 2. Now that we've rewritten it with a power, there's absolutely no reason we can't differentiate it normally, right? dy dx equals half times x to the power of negative half. Does that make sense to you? We simply took the old power, 1/2, and moved it to the front, and then we took away 1 from the power, which decreased it from 1/2 to negative 1/2. So let's look at this equation here. Y equals the 4th root of x plus 12x plus 3. The 12x and the 3 parts aren't going to cause us any stress when it comes to differentiating, but what about the 4th root of x? It's easy to turn the 4th root of x into something with a power. Y equals x to the power of 1/4 plus 12x plus 3. Great. Now that's the hard part over and done with, and we can just differentiate this thing normally. X to the power of 1/4 becomes 1/4 times x to the power of -3/4. 12x becomes 12, and 3 disappears altogether, never to be seen again. So our answer to this once horrible looking equation is simply dy dx equals 1/4 times x to the power of -3/4 plus 12. No sweat, right? Good, because now we're going to move on to something a little bit different. Take a look at this lovely thing. Y equals 1/x. Let's say the exam asked you to differentiate this. What would you do? Y equals 1/x doesn't necessarily look like it'd be hard work to differentiate, but where would you begin? Once again, there's no power to help us out. Panic! No, wait. All we need to do is rewrite 1/x like this. Y equals x to the power of -1. Aha! So after only a small amount of mathematical witchcraft, we've turned it into something that we can differentiate. Dy dx equals -x to the power of -2. The -1 got brought down to the front, and then the power got lowered from -1 into -2.